In the last video, we looked at integration and in particular standard results. In this video, we're going to look at another integral involving an inverse trig function. If we take now the integral of 1 over the square root of a squared minus x squared and we integrate with respect to x, the standard result is the inverse sine of x over a plus a constant of integration. So both c and a are constants. Sometimes we'll see this written as arcsin of x over a plus a constant. So depending on which course you're doing or which textbook you read, these are the standard results from the integral of 1 over the square root of a squared minus x squared with respect to x. So let's go ahead and look at how we found this standard result. So if we let x be equal to a sine theta, we can differentiate both sides with respect to theta. We have dx d theta will be equal to a cos theta. So we can write that dx will be equal to a cos theta d theta. So using integration by substitution, we now have the integral of, and then in the numerator, we're going to have a cos theta d theta, simply using the substitution for dx. Then in the denominator, we're going to have the square root of a squared minus, and then we have x squared. So that's going to give me minus a squared sine squared theta. So just using now x is a sine theta, I've gone ahead and substituted that in. So the square root of a squared minus a squared sine squared theta. Let's go back to a basic trig identity. Cos squared theta plus sine squared theta will always be 1. So we could write now that cos squared theta was equal to 1 minus sine squared theta, and we could say that cos theta was equal to the square root of 1 minus sine squared theta. All I'm going to do at this stage is factor the denominator and then write it in this particular form. So what we have then is the integral of a cos theta, and then in the denominator, factoring this, we have the square root of a squared 1 minus sine squared theta, and we're integrating with respect to theta. So if we look at this now, we have the square root of a squared, which is just going to give us a, and the square root of 1 minus sine squared theta. So we can write that this is going to be the integral now of a cos theta over a cos theta, and we're integrating with respect to theta. So essentially we just end up with the integral of 1 with respect to theta, which quite clearly will give us theta plus a constant of integration. So integrating 1 with respect to theta will give us theta. If we look at this stage right here, we've let x be equal to a sine theta, so we could say that theta is going to be equal to the inverse sine of x over a. So simply dividing both sides by a and taking the inverse, we've got theta is equal to the inverse sine of x over a. So writing that out, we end up now with the inverse sine or arcsine of x over a plus a constant of integration. So let's just write out arcsine of x over a plus a constant. And this gives us now the standard results that we can take from the formula book and quote. Generally, you won't have to derive these. You simply use the particular result for the question that you're given. So, like in the last video, what we're going to do is work through a range of examples and look at applying this. Let's start off now with the integral, and we will take the integral of 1 over the square root now of 81 minus x squared, and we're going to be integrating with respect to x. So we can see that this falls into now the particular pattern of 1 over the square root of a squared minus x squared. So in this particular case, we can see that a squared is going to be equal to 81, therefore a is going to be equal to 9. So we can simply write this out now as the inverse sine or arcsine of x over 9 plus a constant of integration. Or if you like, arcsine of x over 9 plus c. So all I've done is match this up to the standard integral and gone ahead now and simply written the result out. Let's look at another one. Let's say we have now the integral and we have 4 over the square root of now 1 over 25 minus x squared, and we're integrating with respect to x. Often I like to take the constant to the left hand side of the integral sign. We certainly don't have to, but it might make our life slightly easier in spotting this as a standard result. When we look at these, sometimes we think it's a case of using the chain rule. We would have to have some multiple of x in the numerator to reverse the chain rule from this, as that would be the derivative or part of the derivative of the denominator of this fraction. So some multiple of that. So what I'm going to do is put this such that I can just equate it to a standard result. So we can see here that a squared is 1 over 25, therefore a will be equal to 1 over 5. So what we have here is 4 lots, and we can write this out. We have 4 lots of the inverse sine now of x over 1/5, which will give us 5x plus a constant of integration. So all I've done is taken this, I've fitted it now into the formula given in the formula book and simply plugged in a to write it as 4 lots of the inverse sine of 5x plus a constant, or if you like, you could write 4 arcsine of 5x plus c. And that gives us now the standard result after we integrate now 4 over the square root of 1/25 minus x squared with respect to x. Let's look at another one. What we're going to have this time now is the integral of 2 over the square root now of 9 minus 4x squared, and we're going to integrate with respect to x. So if we look at this time now we have a coefficient on the term in x squared. The coefficient is going to be 4. So what we need to do is factor that out. If we look at this now, we'll have the integral, and we could take the 2 to the left, it's entirely up to us. We could now write this as 1 over, taking out 4, we're going to have the square root of 4 multiplied now by the square root of 9 over 4 minus x squared, and we're integrating with respect to x. So what I've done here now is taken out this factor here of 4, and it's the square root of 4. A common error is to write this as 4. It's going to be the square root of 4 as we've taken it out from under the square root. So this is going to give us 2 over 2, the integral of 1 over the square root of 9 over 4 minus x squared. We're integrating with respect to x. So at this particular stage, we can quite clearly see that's going to give us 1, and we can state that a squared is going to be equal to 9 over 4. Therefore, a is going to be equal to 3 over 2. So we could now write this as the inverse sine of x over 3 over 2, which would give us 2x over 3 plus now a constant of integration. Or if you like, arcsine of 2x over 3 plus c. So all I've done now is simply written this in the form that we're given in the formula book, taken a squared to be 9/4, taken the square root and used the standard result. This cancelled to give us 1, so we just write it out now as the inverse sine of 2x over 3 plus a constant, or arcsine of 2/3 x plus c. Entirely up to you based on the notation that's in your particular course. Let's look at another one. Let's put some limits on this one. Let's go now for the integral, and we will have the integral from 0.2 to 0.4. Let's take 0.4, and we will have now 1 over the square root of 1 minus 4 x squared, and we're going to integrate with respect to x. So if we look at this here, again, I've got a coefficient on the term in x squared. We need to factor this out to put it in the standard form. So what we're going to have is the integral from 0.2 to 0.4. Again, I'm going to take this out. Now, if we had, for example, 1 minus the 9x squared square rooted, we could take out now the 9. This would give us 3, then we'd have 1 over 9 minus x squared. So what I've done here is taken out the 9, but as we've got the square root of 9 is 3. Another example now, if we had the square root of, let's say we had 25 and then we had minus 49x squared. Taking out the 49, if we square rooted that, we would have 7, we would have the 25 over 49 minus the x squared. So in this particular case, again, we could see that a squared was 25 over 49, so a would be 5 over 7. So if I do that, what I'm going to have is 1 in the numerator, I'm going to have 2 in the denominator, then I'm going to have 1/4 minus x squared. We're integrating with respect to x. So now I have a standard result. We can say that a squared is equal to 1/4, so a will be equal to 1/2. So what we're going to have then is the following. We've got now 1/2. So taking out now this constant right here, we've got 1/2, and we can evaluate. We're going to have now the inverse sign or arcsin of x over a. Well, x over 1/2 is going to give us 2x, and then we're considering now the integral from 0.2 to 0.4. So we're going to work in radians. If you're doing any integration with trig, we work in radians, and we will give this now to 3 significant figures. So what we're going to have here is 1/2, and then we'll have now the inverse sign or arcsin of 2 lots of 0.4, which will give us 0.8, minus now arcsin, or if you like, the inverse sign of 2 lots of 0.2, which will give us 0.4. So let's go ahead now and evaluate this on the calculator. Some exams will ask you to put your steps here for each of these. I'm just going to put it through the calculator, making sure we're in radians mode. Shift mode 4. So we got 0.5, and then we have now the inverse sign, so shift sign of 0.8, minus now the inverse sign, so shift sign of 0.4. So all I've done is gone ahead and plugged those values in to find now that this gives us 0.25789, and so on and so forth. So let's go ahead and give that now to 3 significant figures, and that will be 0.258. So 0.258, and that now is to 3 significant figures. So all we've done is gone ahead and evaluated the integral and then rounded accordingly. Let's now go ahead and look at another example. This time we're going to look at the integral of 3 plus x over the square root, and we'll have 25 minus x squared. We're going to integrate now with respect to x. Again, the numerator is not part of the derivative of the denominator, or some multiple of that. So what I'm going to do is split this fraction up. We're going to have now 3 over the square root of 25 minus x squared. So if we integrate with respect to x, and we're then going to add that to the integral of x over the square root of 25 minus x squared. So we have now this integral, and we split the numerator. If we look at this one, this is going to give us one of our standard results. So if you like, you could write this as 3 lots of 1 over the square root of 25 minus x squared. So this would give us 3 lots of the inverse sign or arcsin of x over 5. That is one of our standard results. We know that if we have 1 over the square root of a squared minus x squared. This will give us now the inverse sine of x over a plus a constant of integration. So in this particular case, we have a squared is equal to 25. So a is going to be equal to 5. And we have now 3 lots of that. So we've got this one dealt with. If we consider now just rewriting this one here, what we have is x multiplied by 25 minus x squared to the power of minus 1/2. With this particular integral, we could go ahead and use a substitution. Alternatively, we could integrate this by inspection. This is a case of using the chain rule. So let's just write now 3 lots of the inverse sine of x over 5. Now what I'm going to do here is do this step by step. So I'm going to have plus x. I'm going to raise by a power, so I'm going to write this as 25 minus x squared to the power of positive 1/2 divided by the new power. So if I divide by 1/2, I multiply by 2, and then I need to divide through by the derivative of the inside function. So that will be multiplied by minus 1 over 2x. The derivative of minus x squared is minus 2x. So this is what we end up with, and then some constant of integration. If I now consider what's going to happen here, we've got the 2 and the 2 that are going to cancel, and the x are going to cancel. So we could write this now as 3 lots of the inverse sine of x over 5 minus now the quantity 25 minus x squared to the power of positive 1/2 plus a constant of integration. Or, if you like, 3 lots of the inverse sine of x over 5 minus the square root of 25 minus x squared plus c. So, if you're unsure, go ahead and differentiate that, and we should end up now with x over the square root of 25 minus x squared. So all I've done here is use integration by recognition by reversing the chain rule. So quite a tricky integral. We've got 2 parts to it. We've got a standard result, which we can use from the formula book, and then we've got a choice or different approaches for this particular integral, and I've gone ahead and simply used recognition. So our final answer is given as 3 lots of the inverse sine of x over 5 minus the square root of 25 minus x squared plus c. So there are some examples of using standard results when we have inverse trig functions.